Welcome to Challenging Climate, a podcast where we discuss the science, technology, and politics of climate change. I'm Jesse Reynolds, an environmental policy expert.
And I'm Pete Irvin, a climate scientist. Each episode will bring in a guest with a unique perspective and deep expertise on climate change and put challenging questions to them.
In this episode, we spoke with Roger Pielke Jr. He's a professor in the Environmental Studies program at the University of Colorado and the author of several books, including The Climate Fix, What Scientists and Politicians Won't Tell You About Global Warming, and The Rightful Place of Science, Disasters and Climate Change.
Now, I was really interested to speak with Roger because I think he brings some interesting perspective to climate change, showing the ways in which both mitigation and the impacts of climate change are kind of embedded in a broader challenge of economic development. I don't agree with everything he says, but he brings in some really interesting ideas that I think a lot of people in the climate community should internalize.
What I see a lot in Roger's work is an insistence that public communicators, including climate change scientists, speak in a way and conduct their research in a way that's consistent with the best available evidence, including that from the IPCC. So in a way, you can see him as holding the feet of climate change scientists and advocates to the fire. And he's come under a lot of criticism and been accused of being a skeptic, contrarian, or even a denier of anthropogenic climate change. And he was subject to a smear campaign throughout the 2000s that was effective enough that when I returned to the issue of climate change around 2009 or so, I assumed that everything I had heard about him was more or less true. I read The Climate Fix, his book from 2010 or so, about how the climate change problem needs to be confronted with a certain realistic assessment of the difficult trade-offs around development, as well as the limitations and promises of aggressive mitigation. Roger, welcome to Challenging Climate.
Thanks for having me.
Tell us a little bit about your background. I know that your father is a fairly well-known atmospheric scientist. You're a political scientist who studies the intersection of policy and science. How did you end up where you are now?
It's always interesting having a chance to look back. Everything looks like a straight line when you look backwards, and when you were running it forwards, it wasn't always so straight. As you said, I grew up in a household. My mom was an elementary school teacher. My dad was a professor, atmospheric scientist. Apple doesn't fall far from the tree, so I always thought I would go into the sciences and was headed that direction. Got a math degree as an undergrad. And I worked at the National Center for Atmospheric Research in Boulder as a computer programmer. One of the benefits of having a atmospheric science father is I learned Fortran when I was, I guess, soon after learning how to walk. And turns out that was a marketable skill. So as an undergrad, I worked at the National Center for Atmospheric Research as a programmer. And I heard all these scientists say, the world would be a much better place if only these damn politicians understood science. So I said, I'm going to get ahead of the academic competition. I'm going to get a master's in public policy. And that took me to Washington, D.C., served for a brief moment on the staff of the House Science Committee. And I heard the staffers, all brilliant people, PhDs, lawyers, they said, if only these damn scientists understood politics, the world would be a much better place. And that, for me, was kind of close the circle between, scientists don't think the politicians have it right. Politicians don't think the scientists have it right. I think I found my niche. So I didn't go back to the sciences. I went and got a PhD in science policy. And, here I am 25 years later.
You're most famous, or perhaps infamous, for your work on climate change. So how do you describe your work on climate change?
My work on climate change has always been, problem-oriented, policy-focused, and ideally scientifically rigorous. And I did my PhD in the early 1990s on the use and misuse of climate science in policymaking. At the time, it was, a ridiculously niche topic. I mean, who cares about science and climate change? Climate change wasn't even a big deal back then. And at the time, my PhD work came to the conclusion that we were doing a lot of interesting and good science. This was kind of at the dawn of big time climate modeling. But I came to the conclusion that all this modeling and projecting the future to 2100 necessarily wasn't the information that policymakers needed for mitigation and adaptation on timescales of this year, next year, 2 years from now when there's the next election. And so closing the gap between what many in the scientific community think is interesting and what many in the decision-making world think is needed has really been a key focus of what I've tried to work on. And I've been lucky. I've been doing this long enough. I worked on a lot of aspects of adaptation, mitigation, geoengineering.
What I'd like to begin with, and what might occupy a good chunk of time here in the first half of our episode, is discussing a few ways in which your writing and your speaking have been somewhat critical of some climate scientists, climate change communicators, and advocates for action on climate change. And the first of these three regards the political feasibility of aggressive mitigation. In this area, you've been relatively pessimistic. Whether that's realistic or not is another question, but relative to those climate change scientists and others, you've been relatively pessimistic, perhaps best captured in your iron law of climate change, that when policies focused on economic growth confront policies focused on emissions reduction, it is economic growth that will win out every time. Could you explain a little bit of your thinking behind the iron law, what inspired it, if it's been borne out?
Yeah, there's a lot there that we could talk about. And let me say, one's judgment of pessimism or optimism, always comes from your baseline expectation. And I have to say, my outlook as a policy analyst is extremely optimistic. And I'm optimistic on dealing with the challenge of climate change as well. In fact, I think in order to survive a career doing policy work, you kind of have to have an optimistic orientation, or else it'd just be too depressing. This can-do attitude that we as a collective species can act together. It's kind of ridiculous if you think about it, but I do think that we can use the tools of knowledge and the Enlightenment to further that goal. The iron law of climate change, and let me say, I've written a lot and I've written a number of books, and it's really interesting. You never know what people will pick up on and what will have traction. The iron law has really been one concept I was introduced in my book, The Climate Fix, that's still being discussed. And it derives from something called the Kaya identity, which is a simple identity, a formulation that was put together in the 1980s by Yoichi Kaya, a Japanese scientist, to develop long-term projections of carbon dioxide emissions to feed into physical climate models. And turns out the Kaya identity is an enormously powerful tool for doing policy analysis. And in brief, it says that we have two levers from which we can address carbon dioxide emissions. One is GDP, and the other is technologies of energy consumption and energy use. And there is this debate, and it's fun in the classroom, about circular economies and degrowth and things like that. The starting point, we have to realize that there are billions of people on planet Earth who lack the access to energy services that you or I do. And it's just remarkable. And many times they're invisible in the climate conversation. At the same time, even in rich countries, there are people who are struggling, who have relative deprivation or poverty, and also don't enjoy the material or energy access that you or I do. I think it's a simple statement that no politician on the planet in democratic societies or elsewhere has ever had a successful career campaigning on making people less wealthy. My students all want to get jobs when they graduate. After they get jobs, they want to get raises. We like to travel to warm places on airplanes. We like the benefits of economic growth and energy consumption. Now, not everybody does, but as a global society, I think it's inevitable that the world will consume more energy in coming decades, and nations and individuals in a global collective are going to strive for economic growth. And if you look at the G20 summits or the UN Security Council or any collective of international bodies, the one thing that policymakers around the world consistently agree on, even as they can't agree on anything else, is the importance of the global economy. So all of that is to say, yes, mitigating carbon dioxide emissions is extremely important, but on our policy control panel, GDP is not a dial that has much meaning for reducing those emissions, particularly down to zero.
That's a useful explanation of the iron law and how it derives from the Kaya identity, but I do get the sense that, relatively speaking, relative to most public messages around the prospect of emissions cuts, that your message is somewhat out of step from the many climate scientists and climate action advocates. Am I wrong? And if not, what's the reason for this disagreement between you and this wider community?
It's possible, but let's get specific. I mean, who are you thinking of? What messages of mine do you think are out of step with whose and what they say? And let's unpack it a little bit, and happy to discuss it.
The sense I get from most publicly visible climate change scientists and advocates of change is that we can eliminate greenhouse gas emissions in the next few decades. If you go back to the Climate Fix, which was published, I think, in 2010, there's a graph of, I think it's the share of energy that comes from renewable sources or zero emission sources. And it's more or less been flatline for decades. And you draw a line diagonal down to where it needs to be zero by 2050 or so. And you say, look, it seems politically unlikely. And I was going back through some of your writings, and I get the sense that it was stronger. I read something of yours in 1998 where you used the phrase that recent experience provides a reason for restrained optimism at best and outright pessimism at worst. And then by 2010, it's more measured, but still nevertheless not enthusiastic about the political, technical, and economic feasibility of the necessary mitigations. Am I wrong about this disjunction?
If there are people claiming that we can eliminate greenhouse gas emissions in the next several decades, I would disagree. The world still gets upwards of 80% of its total energy consumption from fossil fuels. There is no IPCC scenario which foresees zero CO2 emissions or net zero CO2 emissions by 2040 or 2050. I do think it's conceivable that that can be achieved in the period between 2050 and 2100. But if you do the simple math, as you say, you're absolutely right. There's no technological obstacle to getting at least very close to zero CO2 emissions. And you can just do this with a math exercise in your head. There's something like 7,000 fossil fuel power plants worldwide. And if you just say in your head, all right, let's just replace each one of those with a nuclear power plant, set aside whether you like nuclear or not, between now and your target date, that tells you how many have to be built every day. Oh yeah, and then we have to add all that new energy consumption for all those people gaining true access to the grid. It turns out that number, which hasn't changed very much over the last decade since I first did this analysis, since Marty Hoffert first did it in 2001, is about a nuclear power plant a day. And that's a lot. And whether you convert that into wind turbines or solar or geothermal, pick your favorite, it's a huge effort to get to zero CO2 emissions. I am optimistic that it can be done, but I think those who say we can do it in the next few decades are discounting the political and societal factors that make such an energy transition that difficult. I wouldn't say that's pessimism. I would say that's realism that underlies an optimism that we can actually do this job, but we got to get to it.
One element missing from your analysis there seems to be that of distribution. There are many who point out that the wealthiest, say the wealthiest 10% of the US, contribute far more than the rest. And I think there's often perhaps a blending of, or people argue that climate can't be separated from broader environmental or social problems. And one of the problems being inequality. Like, how big a role could tackling inequality, could targeting those high emitters with policies?
So the first thing to say is I'm a huge supporter of greater equality and especially greater wealth for those who don't have access to it. I mean, the reality is that, and I don't know the numbers off the top of my head, but some tiny fraction of people have a majority of global wealth, and the bottom 50% have almost none. But when you talk about the Kaya identity and its role in thinking through emissions, the fact of the matter is the Kaya identity doesn't care about inequality. It's aggregate global GDP that matters. So if there was one person who had $100 trillion of GDP activity, the carbon dioxide implications are exactly the same as if you distributed that equally amongst all 8 billion people. So this is where I think it's really important to separate out I mean, and Mike Hume has written brilliantly on this. If we define climate change as a challenge of reducing our carbon dioxide emissions to zero, that's a different challenge than if we say, well, climate change is more of a social issue about ensuring that everyone around the planet has equal access to energy resources. So we have to be real precise in how we define these issues. But if the goal is net zero CO2, that can be achieved at various levels of inequality in the world. And so at that point, we have to decide, what is it that we want to emphasize? And of course, there's some people who say, yeah, I want to use climate policy to make the world a more equitable place. And I'm all on board for that. I think that makes a lot of good sense. One of the things I've talked a lot about over the years is that we can't talk about net zero CO2 without having in the conversation expanding energy access to those who don't have it at the exact same time. I'm fully on board with saying climate change is not just a CO2 issue, but once we start bringing issues to the table, it becomes a lot more complicated.
Now, I guess eliminating global CO2 emissions by 2040, 2050 would be very challenging. But can you see that happening? US, Europe, are these developed countries more able to achieve that goal?
Yeah, absolutely. The first big step that we're seeing in countries that are, long-time energy consumers is getting rid of coal. And so in the UK, coal is just about gone, partly due to energy policy, partly due to changing nature of the economy. The United States, if current trends continue, then the United States will be out of the coal business by early 2030s. But, at the same time, there are much bigger energy consumers in China and India where coal energy is perhaps not peaked yet and is still massive, much larger than anything in Europe or the United States. This is why the transition to carbon-free is difficult, because not everyone's starting from the same place. And obviously, a country like France with a strong nuclear base and apparently not a lot of opposition is better positioned than a country like Germany. A country like Sweden or Canada with a lot of hydro resources, obviously much better positioned. So not everyone starts in the same place and not everyone's heading to the same direction. In the United States, for example, long-term projections are that energy consumption is not going to rise. It's flatlined or maybe declining a bit, but that's not the same for large parts of the world where energy consumption starts from a very low base and is expected to increase.
So another area where you've been quite critical of the climate community is in the use of scenarios. And I think you put this very strongly in a recent paper. You said something along the lines of, the continuing misuse of scenarios in climate research is one of the most significant failures of scientific integrity in the 21st century thus far. So what exactly is the problem here? What have you been concerned about?
One thing to understand is, and I think the climate community, because the cause of climate change is so worthy, that criticism or critique is often, I found, viewed much more personally than in other areas. Policy researchers critique. People in the science technology studies community study science and offer critiques. And we do this in medicine, we do this in engineering, we do this in all sorts of fields. So the climate community is so important that it's deserving of critique. And so people shouldn't take it personally. But let me say on scenarios, oh my gosh, the issues here are crucial. And the short story is that we are using scenarios out to 2100 to underlie our projections of physical climate change, to underlie cost-benefit analyses. These scenarios were developed a decade, 2 decades, sometimes longer ago. And scenarios are a little bit like milk. If you keep it in your fridge too long, they spoil and you don't want to drink them. That's not unusual or strange or personal failing. It's a fact that as we move into the future, some futures we once thought were plausible become implausible. And through technology, through politics, the future changes. And we are doing a disservice to research and to policy by continuing to rely on scenarios that are like spoiled milk. And the problem isn't that scenarios drifted out of relevance. The problem is that once the community has become aware of this, there's this stubborn insistence on continuing to use them. And I get it. There's institutional momentum. You can publish a lot of papers using these off-the-shelf spoiled scenarios. And in some cases, they're politically useful for this or that interest. But the reality is, in 2021, there's no excuse for anyone in the climate science community not to understand that the scenarios that underpin research and assessment are hopelessly out of date. And that is not a really debatable proposition for anyone who understands the scenarios.
Well, should we focus on the upper end scenarios, the so-called business as usual scenarios, known as the representative concentration pathway, the RCP 8.5 and the new SSP 8.5, these high-end emission scenarios. This is where I think the bulk of your criticism has been focused. Could you give a little explanation of what those scenarios are and how they're used in climate science?
So scenario planning is really important because, and this goes back to the 1960s, we're not really good, and then some would say it's really impossible, to predict long-term futures. And there's a lot of reasons for that. It's technology, politics. If you look at energy projections from the 1970s, they got off track really fast. And so we use scenarios to develop plausible futures to help us guide our decision-making to take us where we want to go. Scenarios aren't predictions, but they have to be possible. They have to be plausible representations of futures that could occur. In the climate community, there has been a long-term, many decades debate over what the role of scenarios is. On the one hand, there's a contingent that says, well, scenarios should underpin conditional projections of what the future will be. And there's other people who say, well, no. We can't even do conditional projections. Scenarios just have to be plausible representations of possible futures to allow us to choose among them. It's a key difference, and it's fundamental not just to climate, but it's across the whole field of scenario planning. With the so-called business as usual scenarios, they were originally developed in principle to provide an baseline expectation for where the world was headed in the absence of intentional climate policies. So in a sense, you cannot separate the notion of business as usual scenario, which is also called a reference scenario or a baseline scenario. The exact terminology isn't important, but the idea that we can establish a trajectory that we are on and that we expect to follow to 2050, 2080, 2100, and we can evaluate policies based on our deviation from that scenario. All of that hinges on an expectation that that actual scenario is a plausible representation of the future, if not the most likely future in the absence of certain policies. Both of those can be contested, but let's just take that as a starting point. What happened around 2005 is that the climate community, and again, it was a community decision, decided to remove considerations of plausibility from its selection of scenarios. In fact, it was the needs of climate modeling that dictated which scenarios were selected for prioritization. And if you're a climate modeler, you want a very high-end scenario that you can force a climate model with a lot of radiative forcing and carbon dioxide emissions to see what happens. You want a very low scenario so you can see, well, what might the alternative be? That makes sense. It makes a lot of sense from a research standpoint. What's missing there is when you take the results of that research and bring it to the real world, you need to know, is that future even a plausible one? And so for RCP 8.5, it assumes that the world is going to build the equivalent of 33,000 new coal-fired power plants. That's in addition to the about 6,000 that exists today. So we are going to increase by a factor of 5 or 6 the amount of coal energy on the planet. We're going to replace nuclear. We're going to replace natural gas. We're going to replace hydro. Eventually, we're going to replace petroleum because we're going to get liquid fuels from coal. That's what's needed for RCP 8.5 to be in the future. That's just one element. That's not going to happen. I can say with 100% certainty that the world is not all of a sudden going to decide we're going to put all of our chips on coal energy. It's just not going to happen. The world is moving in a very different direction. So the splitting of the needs of climate modeling from evaluations of scenario plausibility created what I and my colleague Justin Ritchie, and I have to give Justin all the credit in the world because he labored on the RCP 8.5 issues for years, and his doctoral work had trouble getting it published, and really deserves all credit for bringing these issues forward into the climate community. We call this a scenario plausibility vacuum. There is, in fact, no one's job in the IPCC or in the CMIP process or anywhere else there's no one's job to evaluate whether the scenarios we're using in climate research are actually plausible representations of the future. So we've done a lot of research by now on evaluating scenario plausibility. And it turns out that the high-end scenarios are empirically implausible. And that's something, we could talk about the numbers and we could debate that. But if they are implausible representations of the future, they have no place being used in research to inform policy. Sure, you can drive climate models and do all sorts of interesting exploratory scientific work, but let's not confuse that with the sort of information that decision makers might need, or cost-benefit analyses or climate impacts and so on.
I agree that the quintupling of coal consumption per capita by the end of the century seems very unlikely. But I've heard it argued that the emissions trajectory that the world has followed has been tracking closer to the upper end of earlier projections over the past decades. And if you use that historical basis, we're sort of on track for a high emission scenario. So maybe could you unpack a little more on the implausibility and why we're definitely not on this high emission scenario?
The first thing is that's not actually the case. If you take a look at the Global Carbon Project, you do this with or without land use projections. Right now, the world is bang on the middle scenario, RCP 4.5. But at the same time, I want to urge caution that we can't use short-term, so decadal, evolution of emissions or technology or really anything in a scenario as the basis for a projection out to 2100. Because there's no guarantee that current or recent trends persist into the future. The example I always use here, if I track the growth of my son from when he was 10 until 15, I could say, well, he is on track to be 29 feet tall by the time he's 26 years old. And obviously, there are reasons why the growth rate of my son when he was 10 to 15 won't persist until he's in his late 20s. It's the same thing with the energy system. We can't take carbon dioxide emissions of a very short period and say this is the century-long projection. We have to go more into fundamentals of our understandings of theory, of technology, and so on. And the fact of the matter is there was a brief period, probably associated most with the China's build-out of coal energy in the 2000s, where it looked like the high-end scenarios were being matched by what was happening in the real world. But if you look at the literature, you look at energy studies, you look at people with actual expertise in the energy system, we can go back, and RCP 8.5 should never have been viewed as a plausible scenario to 2100. We can debate that as a matter of historical interest, but in 2021, it should be obvious to everyone just based on the empirical reality of what's happening around the world.
I should say I am a climate scientist, and some of the work I've been doing, and I think some of the work I will do over the next few years, will have to rely on these upper end scenarios because there are no other scenarios that have been run for the solar geoengineering simulations that I look at. So I agree that I think these high end scenarios look unrealistic now. And going forward, we should redirect our energies towards those more, what used to be middle ground or sort of current policy scenarios. But I feel with your statement that, this is one of the most significant failures of scientific integrity in the 21st century. I wonder if that's a bit strong here, because I think later in that same paper, you note just how many papers come out each week that use these scenarios. And I guess I want to say, I feel, yes, these scenarios are unrealistic, or the high-end scenarios are unrealistic. And there is a danger of inadvertently communicating that you think they're likely by using them. But if appropriately used, can we not take what's valuable from these scenarios? I mean, there's an enormous investment of computational time. There's huge numbers of simulations that we conduct that will have enormous scientific value that we can extract over the coming years. I guess an extreme take on your view would be we should just throw them all out and never use them again. Can we not still use them if we're careful with our communication?
We're really careful to say that there is, of course, a role for extreme scenarios. And the distinction that you make is an important one, and it's not made often enough, is between exploratory research, where you want to learn something. You want to learn something about models. You want to learn something about the real Earth system. And geoengineering doesn't exist either, but the only way we can explore it often is through modeling and through exploratory studies. But you, and I know your work, and I think it's great, you don't go around saying, here's my prediction of how much geoengineering we're going to have in 2080. What you do is you say, these are hypothetical futures from which we can learn something. And I mean, I'll tell you, Justin Ritchie and I published a more popular version of our scenario critique. And the head of the National Academy of Sciences and a former lead author of the IPCC wrote in a letter responding that RCP 8.5 is, in fact, the BAU, business as usual scenario that the world is on. If leading scientists can't admit that we are already far off track of RCP 8 in 2021, forget about projecting the future. If you look at the data today, we are way off track from that. If that can't be admitted, then yes, I think it's fair to call that a serious failure of scientific integrity.
Roger, most of your critique of scenarios feasibility has went toward the upper end of scenario projections. What about there at the lower end? You look at RCP 2.6, sorry for so much climate lingo, but that is the relatively optimistic scenario that was used since about 2010. It has global greenhouse gas emissions reaching net zero around 2070 and is then followed by net negative emissions through carbon dioxide removal at an enormous scale. I think it gets up to close to 10 gigatons per year, maybe not quite. And if such carbon dioxide removal is not reached, then net zero would need to be reached early. Is it your sense that RCP 2.6, the new report from the IPCC, has even more optimistic scenario? I think it's RCP 1.9. Is that also so unlikely that it should be taken out of the scope of possible futures?
There's two answers to that. So one is we have a paper with Matt Burgess and Justin Ritchie. You can see a preprint online, and it's been revised. I think it'll be published shortly. But what we did is we took the 1,311 scenarios, a massive number of scenarios in the IPCC Fifth Assessment Database, and also from the so-called SSPs, a lot of lingo. We took a whole bunch of scenarios. That's the starting point. And we asked the simple question, which one of those scenarios are most consistent with how the world has evolved since they were initialized in 2005? And then we also compared them to the projections of the International Energy Agency out to 2050. The International Energy Agency represents a consensus of energy experts on near-term energy trends. And they've been right and wrong in various degrees, but they represent a current consensus that's independent of the IPCC work. So when we take those 1,300 scenarios and we say, all right, which ones of those are most consistent with near-term trends, near-term projections also, we get a much smaller subset. And then the next question we ask in our research is, all right, let's take that subset of 100 or 200 scenarios that are consistent with what the real world's doing and see what they project out to 2100. And it turns out every single one of the IPCC scenarios that we define as using this method as plausible fall between 2 and 3 degrees Celsius in 2100. So that's on the upper end, that's really good news because it says that some of the 4 degree, 5 degree scenarios that people used to think were plausible on present understandings don't seem to be plausible. But at the same time, there are no scenarios of the IPCC which get below 2 degrees Celsius, which is the goal of the Paris Agreement and aiming for 1.5 degree Celsius. So the point there is that we are in a good position should we decide to up our ambition to try to hit those lower targets. But we're not, on current policies, we're not there yet. The second point I want to make is that when we use scenarios, there's a big difference between outcomes you want to avoid and outcomes you want to achieve. And so what the IPCC did, and this, again, it's a very important exercise. It's an exploratory exercise. It had a report on 1.5 degree Celsius scenarios, and it constrained the scenarios to achieving that goal. They said what would be necessary in order to achieve that goal. Ultimately, we may learn that that goal isn't feasible or it's not possible, but we want to keep on the table outcomes that we may not reach, but we want to strive for. And as we go into the future, if we're successful in policy, the outcomes we want to avoid, we can take off the table and don't have to plan for them. For example, maybe 70 years ago, we'd be planning for a global policy for dealing with polio. But I think in 2021, we can take that off the table as something we don't need to plan for the next couple of years because technology, vaccination has made that possible. So the elimination of scenarios from your view of the future is normal and expected. At the same time, we want to add those into it as we try to make certain futures plausible or possible that maybe aren't today.
The third area where Roger has been somewhat critical of much of climate change communication is extreme weather events. And our timing, in a way, is coincidental. We're recording this episode in mid-December, and the United States, yesterday, I believe it was, experienced a number of tornadoes in the Midwest and into the South. And U.S. President Joe Biden said the fact that we know everything is more intense when the climate is warming. And obviously, it has some impact here. And the administrator of the Federal Emergency Management Agency said, this is going to be our new normal. And the effects that we're seeing from climate change are the crisis of our generation. Roger, can you say a little bit about your interpretation of how the relationship between climate change and extreme weather events is communicated and how that relates to the current available evidence regarding detection and attribution?
After I got my PhD, 1994, I went to NCAR, National Center for Atmospheric Research, to work as a postdoc on extreme weather events. And at the time, this was before extreme weather and climate change were really tightly linked. I came to the climate issue kind of backwards from most people. I came from kind of an adaptation extreme weather focus and later developed expertise on mitigation and energy policies. So I've been doing extreme weather work for an awful long time. And it's important, I think, at the start to say extreme weather, sure, that's a category that's, we talk about particularly in popular discourse, but from scientific understandings to policy response, we really have to talk about phenomena by phenomena, hurricanes, tornadoes, floods, and it matters, drought, extreme heat, because trends and patterns and variability and response are going to be different in many places. Overall, I've seen over the course of my career a huge change in how we in the expert community talk about weather extremes. And it coincides, to some degree with Al Gore's 2006 movie, An Inconvenient Truth, that, had the hurricane coming out of a smokestack. But there was a motivated push by environmental advocates and, bringing in a lot of scientists around that time to bring climate change home to the ordinary person. And the decision, and again, it was a decision, this has been, well documented by scholars like Matt Nisbet and others, but the decision was to make extreme weather the face of climate change, which is fine. That's how promotional work is done. That's how advocacy is done. But at the same time, there's data, there's theory, there's knowledge. And let me say, the current IPCC does a very nice job of summarizing the state of knowledge of detection and attribution of trends in extreme weather. At some point, the popular media discussion departed from IPCC science. That's been the case for a long time. And, we're at the point now where people who associate every extreme weather event with climate change, link it, use whatever connective tissue between those you want to use. Instead of saying something scientific about the detection of trends or their attribution, what people are saying is, climate change is important. It matters to me. And here's a representation of that. And so someone who comes along and says, well, actually, tornado incidents, for example, in the United States has declined over decades. We have good data on that. Seems indifferent at best to the climate cause, because that's not how we speak these days, and maybe unhelpful, maybe even a climate denier. In my classes, I asked students, did Florida have more intense hurricane landfalls in the first half of the 20th century or the second half? And of course, it's the second half, right? That's what they all answer. But the answer is it's gone down by 2/3, and they don't believe it. So for better or worse, I have expertise in extreme weather and policy responses to it. And for me, getting things right is important. And sometimes if that conflicts with popular narratives, that's okay. The data says what it says. Unfortunately, the IPCC has done a really good job. And so the good information's out there for people who want or need it. At the same time, it's okay if there's a little fluff in the public discourse.
We were just talking about two of the most variable and fiddly weather phenomena, tornadoes and hurricanes. They're very kind of, well, hurricanes in particular, like their damage is very unique to the path they take and so on. So these, I guess, are the hardest to attribute and haven't been robustly attributed as far as I understand. On the other end of the spectrum, we do have certain phenomena that are quite robustly attributed to climate change. So extreme heat and some types of extreme precipitation, right?
Yep, that's right. That's exactly what the IPCC has concluded. And that's what you would expect, because as you say, hurricanes and tornadoes are some of the hardest places to detect trends, much less attribute them. For better or worse, heat waves happen a lot. And so we have a lot more data points in our sample, and so does precipitation. So just like global average surface temperature, it's going to be easier from a statistical standpoint to identify trends in those data sets than in much more rare, as you say, kind of fiddly data points that don't allow for such ready identification of trends.
In your writing, I think you've pushed back against this over-attribution of, every weather disaster to climate change. And I guess there's a scientific pushback that in some cases we really don't know, or we can't say with confidence. But I think you've also said that it's ineffective. This potential exaggeration has been ineffective. I wonder if your view on that has changed a little. I feel that there's been but it seems in the past 5 years or so, there's been a growing radicalism in environmental activism, in part driven by, or in part driving, an increased sense of threat from climate change, especially in the youth. What's your feeling on these recent developments? If you were sort of right in your 2010 predictions, wouldn't we have seen a pushback already, and these types of views wouldn't be gaining traction and wouldn't be having such impact on policy?
Yeah, I mean, it's a good question. And, my sense is that to some degree, in some places, and the United States is among them, but also to some degree in the UK and Australia, that some of the political polarization that we've seen develop around climate change, which, let me say, it's an enormously popular and successful social movement. That said, it's still, even, among yellow vests in France and elsewhere, it does get politicized. Some of that may be associated with the willingness of activists to go well beyond what science can support. And I have debates with scientists and activists all the time about whether that's an appropriate thing to do. And this is also tied to our discussion of scenarios. My sense is that the overuse, the repeated use of RCP 8.5 is much more influential than expressions of connection with extreme events, because the extreme events are always there, they're on the newspapers, but for the long-term future, it's the scenarios that project scary futures that may, scare youth and so on. In any policy issue, whether it's weapons of mass destruction in Iraq or it's the pandemic and vaccines, you're going to find that public discourse deviates from what scientists know and don't know in large degree. And that's normal and to be accepted. My sense is climate change is so important that we want the scientific community to be viewed as trustworthy and legitimate for decades going forward. It's not the sort of thing where you're going to pass a policy this year or next year. And so it's really important that we, as a community, call it like it is, stay measured, and push back on excesses it's a hoax side, but also it's the apocalypse side. And that's not always easy to do, because in our community, we often feel like we're on one side more than another. Holding your own side to account can be difficult.
In this context of great polarization, in which one must be seen as being on one side or the other, you sometimes seem to operate sometimes a bit in the no man's land between two polarized sides. And perhaps because of that, you have been subject to some remarkably critical communication and activities from advocates of climate action, from climate scientists, and from figures associated with the Democratic Party. There's a report that recently came out from the Global Warming Policy Foundation that compiles what I think could best be described as a decade plus of persecution of you as an academic and somewhat as a public intellectual. And we'll put links to this report and some of the other papers that you've mentioned and we've mentioned here into the show notes. Can you give as short of a summary as reasonably possible of this persecution, and tell us, perhaps more importantly, why do you think this occurred?
We could talk a long time about this. Let me say from the very outset, I am in an enormously privileged position. I'm a tenured full professor in the United States, and I have a platform where I can call things like I see them, and I seem to have the personality, which may be stubborn or dumb or some combination of that I do that. At one level, the fact that people see my ideas and writings as worthy of such sustained attention and efforts, not so much to critique what my research shows or my writings, but to go after me personally, suggests to me that, maybe they're having a hard time critiquing the actual substance of the work. Let me say, there was a time, I've been working on climate change since the early 1990s and have been a strong supporter of the IPCC and mitigation and adaptation action ever since that time. And I think my track record stands up pretty good. But there was a time when I thought, if I can work to getting, and this is again a parochial US context, but if I can get Republicans on board thinking that climate change is important, I will have contributed something important to the discourse. So I have spent a lot of time trying to demonstrate that we in the climate community are capable of holding ourselves to account. And that means that if a scientist or a policymaker goes too far in what they say, we're going to offer a corrective to them, just like we would to James Inhofe, the Republican senator from Oklahoma who shows up with a snowball on the floor of the Senate. And to some degree, I have been successful in gaining the trust of people who are in many respects opposed to climate action. They don't agree with my policy recommendations. They may not agree with some of my science, but they trust me to call things like I see it. So at some point in my career, I've been invited to testify before the US Congress on many occasions, and I have been invited by Democrats and Republicans. When I first was invited by Republicans, I naively thought, oh my gosh, I cracked the code. Environmentalists are going to be so happy because I'm sitting in that seat testifying, a long-term supporter of climate action and of the IPCC. And when that first happened, I was surprised that instead of saying, oh, this is progress, because instead of a climate denier, they have this guy in there, they said, well, this guy must be a climate denier because Republicans invited him. So it became apparent to me that, at least in a US context, both sides like the political conflict. They like the wedge that it creates, and that building a bridge or muddying that wedge between the pro-climate and anti-climate forces doesn't serve anyone's interest. And I do think that Democrats have done a disservice to the climate issue by making it one of their core issues. And basically, to be a good Democrat, you have to support climate, and to be a good Republican, you have to oppose it. And as a political scientist, I know that you're not going to sustain a coalition for action over decades with a single party support. It's just not going to happen. So yes, it's kind of a no man's land, but it's more populated than you might think. I'm kind of out there and visible, which is fine. But there's actually a lot of folks who don't like the heavy partisan nature that some climate scientists take to the issue, that don't like the fact that Republicans and Democrats are so opposed on this issue. Looking back over my career and last 10 years, I'm pretty convinced that for me, it's been a net positive more than a net negative, even though there has been some tough moments.
I'd like to try to put myself in the shoes of strident advocates for climate action, among which are some climate change scientists, and imagine how they view you. Your writing has emphasized natural climate variability and the inevitability of some climate change. You point out that climate change isn't making natural disasters worse. You use language like dodgy science and what scientists won't tell you about global warming, and how some of the work is much closer to theater than to scientific rigor. And this language is relatively compatible with the views and the language of climate change skeptics and obstructionists. And in fact, to some degree, they have embraced you as a cause to be celebrated. And it's not just them embracing you. You regularly give talks to organizations that I think could be called a climate change skeptic or contrarian or perhaps even denier. That's a term I'm not a word I'm not super fond of, but to the extent that means anything, I think would apply to groups like Climate Intelligence and Irish Climate Science Forum and the Global Warming Policy Foundation. And I suspect that many climate scientists and advocates see you giving a bit of a nod and a wink to climate change skeptics and obstructionists. And so you end up being accused of providing important cover for climate change deniers. And why not, given that you're operating in a polarized environment, which the environment shouldn't be polarized, but that's outside of our control, why not distance yourself from those with whom you are being accused of furthering their objectives? Why not say, look, not only do I advocate for aggressive mitigation, which you have done for decades, but say, look, I'm not going to further the cause of skeptics, deniers, and obstructionists by speaking at their forums and publishing in their outlets.
There's a couple of responses to this. So the first one is, and it's exactly what I just described. It's the idea, if you speak to someone with whom you disagree, you're doing something wrong or supporting them. So I'm an expert in my field. There are people who agree and disagree with it. If I only accepted invitations from the people who already agree with me, that would be pretty much a waste of my time. I am happy to go speak to anyone who would like to hear my expertise. And if they agree with me, that's even better because I've done my job. So I reject the notion that I should distance myself from people I disagree with. As a policy scholar, and let me just say, in every presidential election I've been eligible to vote, I voted for a Democrat, except when I voted for Ralph Nader of the Green Party. I am happy to go visit any Republican forum or elected official that's out there, because guess what? They're the ones who need to hear this message most. If I get invited to talk to the Sierra Club about climate action, it's kind of a waste of my time. And it looks good, and it would be a circle of shared interest, which we see online where people only talk to people they agree with. But that's not my MO. The second is, if you go online and you look up, Roger Pielke Jr., you will find this cartoonish image of a person that I don't even recognize. I don't publish with climate skeptic organizations. Never have. I have given a talk to the Global Warming Policy Foundation in London one time. I was invited by a Republican student group to speak at the University of Minnesota one time. And recently I was invited by this Irish group to give a talk to them online about the IPCC. And I gave an accurate representation of what the IPCC said on scenarios and extremes. Happy to do so in all three cases. Over my 25-year career, I've given like 1,000 talks, maybe something like that. I get a lot of speaking invitations. The fact that people online and some scientists identify these 2, 3, 4 talks I've given to organizations they disagree with to try to delegitimize me, I mean, it's a sad statement of where science is. I'd much rather people say, oh, look at this most recent paper Pielke did, here's where it's wrong. But if the idea is my writings and speaking are inconvenient to someone else's politics, that's their problem, not mine. And if the suggestion is I should change my behavior to facilitate their politics, boy, that's not really what a tenured full professor is supposed to be doing. So as I go forward, if I'm invited to testify before Congress, I'm going to testify before Congress. If it's a Democrat, if it's a Republican, people have to understand it's political, no matter which party invites you. Am I only going to testify when invited by people I vote for? Well, I'm paid for with tax dollars here in the United States. It would be probably improper if I say I'm only going to represent Democrats, not Republicans. Are there some scientists who are widely respected and celebrated who get things wrong on climate? Yeah. Am I going to call them out when they do? Yes, I am. That's my job. Am I going to get things right sometimes? Yes. Am I going to get things wrong? Yes. That's how things work. But I wholeheartedly reject the idea that I should adapt my professional behavior because somebody thinks it's inconvenient to their politics. I happen to believe that engaging with political opposition is important for all of us. In fact, climate skeptic organizations, whoever they happen to be, would benefit from many more scientists going in and talking to them and getting face to face and realizing they're people. They have places where they agree and places where they disagree. The idea we have to build a wall between warring communities is, I think, part of the venom that's been injected into the climate issue.
It seemed like you took a step back from climate change for a few years and are now re-engaging. So I just wondering, what are your future plans for working on climate change? Have you had enough, or are you writing a new book?
In 2015, I was investigated by a member of the US Congress. And I have to say, there's a few things that I wouldn't wish upon my worst enemy. And that's one of them. At times, I felt like my job was threatened, even though I'm a tenured full professor. I've only been invited to give 2 or 3 talks on climate in the 6 years since that happened. That basically forced me out of the community. The accusation was that I was taking money under the table from fossil fuel companies. Of course, I wasn't taking money from fossil fuel companies, but that's sort of an accusation sticks with you. Professionally, I can't go to an AGU conference. I can't go to the EGU. I one step away from the devil for many people who have only encountered me through the stories that are told online. So in many respects, I'm outside the community and kind of an independent operator. I'm doing good research and lately on scenarios. And for now, I'm happy to be re-engaged. I did some work in sports governance, met some great people, and have a second career in that area. I am trying to sell a new book, which I think will be my last word on climate. It's tentatively titled Our Bright Future, How We Solved Climate Change. Because I am optimistic both on adaptation and mitigation, the world's headed much more quickly in the right direction than we previously thought. I have no illusions. I'm going to be a bad guy outside the mainstream on this issue. There's still, even this week, prominent climate scientists who tell stories about me that just aren't true online. But if you have 200,000 Twitter followers, it becomes true. That said, I have a platform and a voice, and I'm going to keep them. And won't be in academia forever, but for now, things are going pretty.
As a last thought, could you give us, what are some hopeful trends that you see? What gives you hope for climate change?
The biggest reason we should have hope for climate change, I tell people, put yourself in a time machine and go back to the 1920s and go to someone and say, guess what? We're going to take life expectancy from 40 years on average worldwide, and we're going to get it close to 80 years within 100 years. And they're going to say, how in the world are we going to do that? That's impossible. And it would have looked impossible, but we did it. If you go back to the 1950s and 1960s and say, hey, guess what? In the 2020s, there's going to be 8 billion people on the planet, and we're going to be able to feed them all. They would have said, no way, that's impossible. That's crazy. What are you talking about? So one of the stories that I think we need to start telling in the environmental community is a story of success, is a story of can do, that humanity has been up for big challenges in the past, and we have tackled them. Is climate change a huge issue? Absolutely. Is it hard? Yeah, it's hard. Is success going to take many, many decades? Yes, it will. Can we achieve net zero? Yeah, probably not by 2050, but certainly by 2100. Will the climate change? Yes. Are we better able to withstand the climate variability and change? Yes, that too. So I am really optimistic that as a species, we can deal with climate change. We can lift up people who lack energy access and live in poverty. We can continue to feed the world. It is a message of optimism. And I know that doesn't sell well in some environmental circles, but I would much rather see us orienting around, let's get this done, rather than look how bad our future is going to be.
This has been Roger Pielke Jr. You can follow his work by subscribing to the Honest Broker newsletter at rogerpielkejr.substack.com. And he is on Twitter at Roger Pielke Jr. Thank you, Roger, for joining us today on Challenging Climate.
Thanks, guys. It's fun.
Thanks for listening to Challenging Climate. Our music is by Peter Dalchuk, and our website is challengingclimate.org, where you can find the show notes for this episode, including all the relevant links and references. If you enjoyed this episode, please consider sharing it on social media to help us grow this podcast.